All right, the next step in our sequence work is to take those sequences and we're going to write a formula for those sequences to help us find any term number that we want to find. We've written t-tables and you've made a graph. The next step again is how can I find any term? The graphs are nice. They can help you find the first 10 terms. But if I want to know the 100th term or I want to know the 1000th term, I need a formula. That's what writing the equation does. So here to show you how is this used outside of our classroom. What I have here is a stock graph. This is the stock graph for Target. And it says that this time when I copied it, it was worth $66.48. Well, what we can do with our equations and graphs is what they take is they'll take a graph like this, and they're going to draw a line on it. And they may draw a line and say, okay, if the stock price was here, and now it's here, I'll draw this long line and let's say, how much money did this stock make over the last year? And how much were they making per month? Or they may take it and say, wow, here's where it really grew quickly. How much did they make here? Or here's where it lost a lot of money, and they'll say from here. They'll draw lines like this, and they will write a formula for each line to help them see how well the stock was making money going up or how poorly it was doing going down. That's where we're heading with this. We aren't going to have a graph like this to start with. That's why you made your graphs from your Father Time activity. So at this point, you need to get those graphs out. You need a pencil and you need a straight edge. So please stop the video, get out the graphs you made, get out a pencil, and get out a straight edge. Thank you. All right, on here, what you see here, this is an example of one of your graphs. Now, this isn't exactly one of them from the Father Time sheet, so what you want to do right now is kind of watch and follow, go along, see how I do this. Your graph has 4 or 5 dots on it. You've got your term number and your terms. The first thing I want you to do when we do this is we'll take a straight edge and we're going to draw a line. And we're going to draw a line starting from the dot on the furthest on the right, and we're going to draw it all the way back over to our 0 line or the y-axis. So we'll take a straight edge, we'll take a pencil, and we're going to draw a line all the way back to the y-axis and stop right there. The y-axis is the 0 line. We have, this is line 1, line 2, line 3. Well, the y-axis is the 0 line. All right, so if I was actually going to put this in my t-table, I would say that term 0 is where the line hits the y-axis. So term 0 looks like it hits at 2. So term 0 is 2. What I'm going to do now is I'm going to use this line and the dots, and I'm going to try to write a pattern out, and so we can see what would the formula be for this graph. So that way, if I wanted to find term 300, I can use a formula instead of plotting a whole bunch of dots and taking all that time. So here's how it works. I take a look and say, okay, I have to write an equation for this, but I'm going to use a pattern. So to start with, we say, all right, the answer I'm looking for is called the term. So we're going to use the variable t for term. That would be the answers we're getting in this column here, the y column. Column on the right, I'm sorry. Then we have our term number on the bottom, and I'll show you in a little bit how we're going to use that. All right, so to start with, let's take a look at how we get our answers. Our first answer that we had was right here. We had term 1, and the term was 4. If you go to our starting point is what number? Your starting point is 2. So we can say the term we're looking for equals 2. Now my line is going up. If the line is going up, what does that mean for the numbers? That means I am adding to that. Well, how much did we add to it? If you look here, 4 to 6, that's a plus 2. So at 4 to 6, that was a plus 2. So since 4 to 6 is a plus 2, I'm going to add 2 here to get to the first term, 2 plus 2. All right? Now, let's look at how we get to the second dot. If we go back to our starting point, the term for the second dot starts at 2. Line is going up, so we're going to plus. Well, what are we adding? Well, every time I am adding 2, so I'm going to say plus 2. Well, how many times do I have to count 2 to get from this dot where I start up to the second dot? Plus 2, plus 2. I counted that 2 times. So I'm going to say 2 times 2 here. That's how I got the third term, or the second term. Now we're going to move to the third term. Term equals 2 plus, and what am I counting by? I'm counting by 2. So if I start at 2, plus 2 to 4, plus 2 to 6, plus 2 to 8. How many times did I count it? I counted it 3 times. So I have 2 plus 2 times 3. Notice a pattern here. We are always starting each one of these with 2, and I'm doing plus 2 times something. Let's go back to the very first one. If I start at 2 and I go up to 4, how many times did I count that 2? That's right, I counted it once. So let's put a times 1 here since I counted it once. All right, we have enough information now that we can actually write an equation for this line, or a formula. When you write the formula, we say our answer t is going to equal my starting point of 2 plus 2, because we were always adding 2. Now we have to figure out what to put back here. Well, let's see. This number 1, 2, 3 is always changing. What do we write down for a changing number? We write down a variable. Well, we've got to figure out what this variable is. Let's take a look. We have a 1, a 2, and a 3. Well, the first term where we have t equals 2 plus 2, that was this. That equaled 4, doesn't it? What number's directly below the dot? A 1. On our second one, we had 2 plus 2 times 2. That's this dot. That gave us 6. What number is directly below that dot? 2. It's our term number. We do it for the third one. 3. Answer was 8, doesn't it? 3, 8. What number is directly below? 3. So we need a variable here. What's that variable going to represent? Yes, the 1, the 2, and the 3 all come from our term number. So we'll use n for the term number. So we'll put that up here. That our t is for term. N equals our term number. T is for term, n is the term number. So here our pattern is to find my answer t, I'm going to take my starting point 2, I'm going to add to it the number of times I counted 2 or I added 2 to it. That's how we come up with the equation. All right, watch me do another one. Okay, this line went up, this line's going to go down. On this one, we were adding, it's going down, will probably be, that's right, subtracting. So let's draw in the line, starting at the dot furthest on the right. And we're going to draw it back to where we started. Oh boy, this doesn't hit on a nice intersection, so now we got to figure out what to do. Let's see here. All right, so I get back to 0. I got to get my 0 term here. 0 right here. That's my 0. Okay. It's not exactly on a line, but if I went this way, I was always subtracting 3, wasn't I? Okay, so we're minus 3. Minus 3. So we got to go from here to here. Well, this is going back up. So if I'm at 25, what will my 0 term be? That's right. I'm going to, instead of, since I'm going up, hey, that's adding 3. What is 25 plus 3? 28. 28. So that means my 0 term is 28. That means this one starts at 28. Notice that's a little bit above 27. It's not to halfway. This one is counting by 3's, isn't it? So a little bit above there. It looks like it's about 28. If I add 3, I'll get 28. So when I want to write this equation, I'm going to start by saying t equaled 28. Now my line is going down. And what were we doing? We were minusing 3, weren't we? So we say minus 3. That gives me my first term, doesn't it? So how many times did I count 3 there? I counted it once, didn't I? Counted it once. Let's try the next one. How did we get the next number? Okay. term equals starting number 28. We're minusing 3. So how many times, if I start here, I minus 3 once to get to 25. I minus 3 a second time to get to 22. So now I am minusing 3 2 times. To get to the third dot, 28 minus 3 minus 3 minus 3. So my term equaled 28. Oopsie, gotta type better, Mr. Ollenberg. 28 minus 3 times 3. All right, let's take a look at where these numbers come again. Now we can use our formula that the term I'm looking for equals my starting point 28. Since my line went down, that's a minus. We're minusing 3, and the term number n. Because when I did the subtracted the first term, 3 times term number 1, 28 minus 3 is 25. 28 minus 3 times 2, 22. That's where that dot is. All right. Pause the video, take a look at that if you need to, rewind if you need to, but we're taking our starting point. If the line goes down, we subtract. If the line goes up, we add. All right, so 2 things so far. What to do when the line goes up? We start with our term is going to equal my starting point, and this one was plus by how much I was counting by, and how many times I counted it. This one, line went down, term equals my starting point at 28. I had to use 28 here because 28 isn't exactly there, so I figured it out by saying, all right, if I'm going down by 3 this way, the line when I'm going up, that means add 3. So I took my first term, 25, and added 3 and said my 0 term is 28. So I can write my formula and say it's term equals starting point at 28 minus 3 times the number of times I count minus 3. All right, last thing that you're going to see. Let's take a look at this graph. I have my 5 dots here. This one, the first term is 0. The second term is 6. So let's draw in the line. And I'll draw in my line. I'm going to go from the furthest dot on the right. And I'm going to draw it in, and I'm going below, and I'm not hitting my line. That's not a bad thing. What we're going to do is we're just going to take the y-axis. We're just going to draw it down a little further. We're just going to extend it down to see where it's at. Let's see here. Let's look at my scale. 24, 8, I got 0, 6, 18, 24. So I'm going up by 6. Well, if I go up by 6, and I now have to go down, 12 minus 6 is 6. 6 minus 6 is 0. 0 minus 6 is, that's right, negative 6. So we're going to write a negative 6 here. So my starting point on this line is negative 6. So if your line goes below your axis, draw it down a little further. Take a look and say, how much were we counting by on the scale over here? And say, all right, I have to now just subtract a little bit to get down to the new number. So in this one, the starting point is minus 6. So if I try to do this by what we said before, my term, t, equals my starting point of minus 6. Which way is this line going? It's going up. That means I'm adding. And how much am I adding? Let's look at our table. 6 to 12 plus 6. 12 to 18 plus 6. And these are all arithmetic, so we'll always be adding the same number. So plus 6, that means I'm adding 6, and I'll be adding 6, and when I want to find an actual answer, I'm going to take it times the number of times I want to add 6. So term equals starting point of negative 6. How many times do I add 6? Here's 1, here's 2, here's 3, here's 4, here's 5. So always counting by 6. And I say to find the term that I'm looking for, I'm going to then say negative 6 plus 6, the number of times I need to add 6. All right, take your graphs out and try. Give it a shot as best you can. Ask questions as you need to. Refer back to the video. You may have to bring this video back up and look at it again. You've got plenty of time to do that. Don't be in a rush on this one. Don't try to get it done in a hurry. Take your time. I want you to take your 10 graphs, So your assignment then will be this, is to write an equation for all 10 of the graphs you made from the father timesheet. Take your time, you'll do fine. Refer back to the video anytime that you need to. Help one another out, ask me for help. Let's get going.